Okay, we're going to be looking at 10.6, Part 3, Solve Exponential Equations Using Logarithms. And there's actually a couple of different ways that we're going to be looking at this first problem. Here I have 3 to the x power equals 15. Now we've been working with exponential equations that look similar to this, where I could write both sides with the same base, but notice here I cannot write 15 as 3 to some power. So that method is not going to work. So one of the ways that I can do this, or to solve this, is to rewrite this exponential as a logarithm. So I'm going to have the log base 3 of 15 equals x. And I can just put that into my calculator, and I get x to be approximately 2.465. Now, another way to do the same problem, and this is the way that is traditionally done, and this is the way that most textbooks teach this, is to take the log of both sides. So I'm going to have the log of 3 to the x power equals the log of 15. And we're taking the common log here, so I'm not using base. I'm not having to write down that it's base 10, but it's understood to be that. So from here, I use my power rule for logarithms, and I take this x and I'm going to bring it up front of my logarithm. So I'm going to have x times the log of 3 equals the log of 15. Now, log 3 is just a number, just like 4 or 6, right? When you have a number that's being multiplied by x, and you want to get rid of it, you do the inverse of multiplication, which is division. So I'm going to divide both sides of my equation by log 3. So this cancels. So x is log 15 divided by the log of 3. And you can't say that's the log of 5. You have to put it in your calculator like this, and you're going to get approximately 2.465. And one thing I want to point out to you here is that this expression right here, this number, log base 3 of 15, and this here, log 15 divided by log 3, is an example of the relation between your change of base formulas. Right? To find this, if you don't have that log base function of your calculator, you take the log of 15 divided by the log of 3, which is what I have down here. Now, the reason why textbooks traditionally chose this method was because we didn't have calculators, and you had log tables in the back of your textbook, and they were always based on base 10. But now that we have calculators all over the place, this is the easier way to do it. So that's the way that I'm going to be looking at doing most of these problems. So we're going to come on down here and do my next problem. 4 to the 2x power equals 7. I have an exponential. I can write it as a logarithm. So I'm going to have the log base 4 of 7 equals 2x. Now, I need to get rid of that 2 in order to get the x by itself. So I'm going to divide both sides of my equation by 2. So x is going to equal the log base 4 of 7 divided by 2, and I can put that into the calculator, and I get approximately 0.702. Let me scroll down here to get to I think I'm going to need a little bit more room for my next problem. So problem 3, I have 2 to the x minus 5 power equals 9. Again, I've got 1x in the exponent. So I'm going to write this as a logarithm. So the log base 2 of 9 equals x minus 5. Remember that this exponent up here is always going to be the answer to the logarithm. So it's what goes on the right-hand side of my equation there. Now I need to get rid of this plus 5, so I add 5 to both sides of the equation, and I get x to be 5 plus the log base 2 of 9. I like to have my 5 up here in the front, and then whatever I'm going to do here with my logarithm, either add or subtract. So I stick that into the calculator, and I get approximately 0.8170. And the next problem. Here I have 5 to the 3x plus 2 power equals 12. I've got the variable in the exponent. I'm going to write this as a logarithm. Log base 5 of 12 equals 3x plus 2. I'm solving for x, so I need to get rid of the 3 and the 2. I'm going to get rid of that 2 first. Subtract 2 from both sides of the equation. So I have 3x equals negative 2 plus the log base 5 of 12. And then I'm going to divide both sides of my equation by 3. It's going to cancel. So x equals negative 2 plus the log base 5 of 12 divided by 3. Now, when you put this in the calculator, you need to put the numerator in parentheses. If you're going to put this in as negative 2 plus your log divided by 3. Now, if you want to put that numerator in and then press equals divided by 3, you could do that as well. Either way, you're going to end up with approximately negative 0.152 for your answer. Okay, this problem is different because I have variables in both exponents. So what I'm going to do here is take the log of both sides. So the log of 3 to the x plus 1 equals the log of 8 to the x. Now, both of these logarithms are common logarithms, right? There's no base written down here, so they're understood to be base 10. Now I'm going to use my laws of logarithms, and I'm going to put the exponent up front here and here. Now, when you do that over here on this exponent of x plus 1, I have to put that in parentheses because that whole thing is going to be multiplied by the log of 3. Over on the right-hand side, I have x times the log of 8. Now, remember, log 3 is just a number, right? So treat it as such. If you have a number outside the parentheses, chances are you're going to want to distribute it. And there's a couple of different ways that you could do this. You could divide by log 3 first, but I'm going to go ahead and distribute. So I'm going to have x times the log of 3 plus the log of 3. Now, normally when you have a number times your variable, you put the number first, like if you have 4x or 10x. But with the logarithms, it makes it a little clearer to see that you're putting the x times the log of 3, and instead of having the log of 3x, right? If you put the x at the end, you'd have to be sure that you put that log 3 in parentheses or a multiplication sign there to indicate the x is being multiplied by the log. So that's a common thing that you're going to see, as I did over here, x times the log of 8. Now, just like if you had a linear equation, let's say I had 5x plus 9 equals 2x, I'm going to get the x's together and I'm going to subtract 5x from both sides. That's what I'm going to do here. I'm going to get these x terms together, so I'm going to subtract x log 3 from both sides of my equation. So over here on the left-hand side, I'm going to cancel out, so I'll have a log of 3. Now over here on the right-hand side, I can't just say that this is x log 5. I can't combine these. So this is x log 8 minus x log 3. Nothing I can do right now to just combine them. Well, I'm still trying to get the x by itself. So what do I do? Well, let's go back over here and look at what I do with just regular linear expressions. This cancels. And here I have 9. Now we know that 2x minus 5x is negative 3x, but really what you're doing here is you're factoring out an x and having 2 minus 5 in parentheses, and that will get you a negative 3, right, which is going to get you a negative 3x. So I'm going to do the same thing over here. I'm going to factor out an x. So I have the log of 8 minus the log of 3. Now, just like over here, I would divide by negative 3. I'm going to divide both sides of my equation by this number. It's a funny looking number. It's not a nice, pretty little number like 2 or 5, but it's a number. So just divide both sides of the equation by that number. Log of 8 minus log of 3. So that cancels. So x equals the log of 3 divided by the log of 8 minus the log of 3. And remember that when you put this into the equation, you need to put this denominator in parentheses, and that's going to give you approximately 1.120. Okay, so we're back with problem 6 and looking at two powers that have variables in each power. So I'm going to take the log of both sides. So the log of 2 to the x plus 3 equals the log of 3 to the x minus 6. Put the exponents up front. So I'm going to have x plus 3 times the log of 2 equals x minus 6 times the log of 3. Distribute on both sides. So x log 2 plus 3 log 2 is going to equal x log 3 minus 6 log 3. Now I want to get x's on one side and these constants on the other. So I'm going to subtract x log 3 on both sides so I can get the x's on the left-hand side. So I have x log 2 minus x log 3. And I still have this constant here of plus 3 log 2. And that's going to equal negative 6 log 3. Now I need to get this constant of 3 log 2 over on the right-hand side. So I'm going to subtract that. And I'm going to do sort of 2 steps in one. This is going to cancel, and I'm going to go ahead and factor an x out of these 2 terms. That will give me log 2 minus log 3. And over on the right-hand side, I've got my constants. And then I'm going to divide by what's in parentheses, because that's just a constant. So divide both sides of my equation by that number, and I get negative 6 log 3 minus 3 log 2 divided by log 2 minus log 3. And remember that when you put this in the calculator, that numerator needs to be in parentheses and the denominator needs to be in parentheses. And that is going to give you approximately 21.386. Okay, the last problem that we're going to look at is a problem that has e for the base. And notice here, instead of an x, I have a t, and t is going to be standing for time in some of the problems that we're going to do in the next lesson. And just like the problems that we started off with, I want to take the log of both sides here, but instead of taking a common log, I'm going to take the natural log. So I'm going to take the natural log of e to the 0.035t, and that's going to equal the natural log of 20,000. Now over here on the left-hand side, there's a couple of different ways that I could think about this. I could take this exponent and move it up front, and then I would have just the natural log of e, which is going to equal 1. But I should know that by the special properties of logarithms that these are going to just sort of cancel out here, the log and e, and I'm going to have 0.035t on the left-hand side. That's going to equal the natural log of 20,000, comma instead of a decimal. Now you just have a basic one-step equation that you need to solve. Divide by 0.035, and t is going to equal the natural log of 20,000 divided by, that does not look like a 3, try that again, 0.035, and that is approximately 282.96.